A very happy morning to everyone. Thank you for joining us for today's webinar organized by Department of Electrical and Electronics Engineering and Electronics and Instrumentation Engineering, R.M.D. Engineering College. It gives me immense pleasure to welcome our esteemed alumni, Mr. R. Gautham, Application Engineer from Automations. Respected HOD, Dr. V. Tamilchelvi Madam, Head of the Department, Electrical and Electronics Engineering, Dr. H. Lamchilvan Sir, Head of the Department, Electronics and Instrumentation Engineering, faculty members and participants, for today's webinar on recent trends in factory automation. Now I request Dr. V. Tamilchelvi Madam, HOD, Electrical and Electronics Engineering, to present the to introduce the expert on this session.
Oh, I'm Tamil Selvi. It gives me pleasure in starting this session, and I would like to welcome all the participants and our speaker, Mr. R. Gautham. And he is our alumni of 2013-17 batch, and he is working as an application engineer in ROM automations, and he is taking care of the technical projects, and that is they are carrying of different types of industry, automotive, pharma, packaging, personal health care, and they are the authorized channel for Mitsubishi Electric Private Limited for the past 11 years. And you had already attended one session with Prashanth sir, that is senior engineer, and now we are going to attend the session with Mr. R. Gautham, application engineer, and who is the partner of Mitsubishi Electric Private Limited, and they are also providing the sales, service and technical support for the automation driven industries. And I'm very happy to inform you that since he is our alumni, and within 3 years he is having such a profile, great profile in this automation field, and in spite of his busy schedule, I would like to thank Mr. R. Gautham to accept our requisition for conducting this webinar session for the recent factory automation. Participants, it's a great pleasure for us to start this kind of recent trends in factory automation in this period. And nowadays automation is playing a major role, and participants, be safe, always be in home, maintain the social distance. All the best for all the participants. Now I am handing over the session to Gautham.
Hello. Yeah, good morning everybody. Thanks for the introduction, ma'am. Thank you. Thanks a lot. And I'm very happy to meet you all again. Thank you. So, as I said, I'm Gautham, alumni of R.M.D. Engineering College, graduated in the year 2017. I belong to 2013-17 batch. Has some major role in Industrial 4.0. So, I'll be taking you through all this in a short period of time. So first let me introduce what factory automation is. So factory or industrial automation is the connecting up of factory equipments to improve the efficiency and reliability of the process control systems. So there are lots of definitions for factory automation in Google, but this one, this I've chosen because this very well suits the term factory automation. So you would have seen in those discovery channels and all those things, Coca-Cola manufacturing company. And the below pictures, I've taken Coca-Cola as an example because it very well suits this topic. So in those days, in early 1900s, what they used to do is they'll fill each and every Coca-Cola bottle individually. They'll aerate the bottle, they'll place the cap, and everything will be done individually by an operator. So that is also automation, but it was done manually. But nowadays, you can see the picture on the right hand side. The Coca-Cola bottles, about thousands of bottles can be produced in a minute. So this is what we call it as factory automation. So in the left hand side, it shows each and every bottle will be filled individually and aerated, and it will be packed. So you can imagine the time it takes to fill a bottle and give it to the packaging. So this is what we call as factory automation. So the concept of factory automation has played a major role in improving the productivity and quality of the product as well. Here I'm mentioning productivity. You very well know. You can think of manufacturing a single bottle at a time and thousands of bottles in a minute. So this is a very big jump. So this is what I call it as productivity and the quality as well. Because in the right hand side, if you see, the quality of the product is very much improved because the human intervention is totally cut. Because human are prone to make mistakes. There might be some mistakes, filling of the air. There might be some human errors, but in the automation, that is totally avoided. That is completely avoided, and you can present a manufacturing unit with less amount of human error. So that is the advancement in factory automation. So Mr. Prashanth, in the before presentation, he would have explained you about the basic industrial equipments, that is PLC, HMI, and I will be covering all those in practical form. So it will be most of a practical webinar than theoretical. I've got videos also with this presentation. I'll be explaining on that also. So the major important factory automation products that we are using today. So programmable logic controllers. When factory automation, the name involves, these products comes into play. So these are very important terminologies that we have to be aware of in factory automation. Because when students, when they are before entering the factory, they have to have at least a minimum knowledge of what is it and how they are using it. So it will be easy for them to enter into an industry. So the first one, programmable logic controllers. So the decision making of a controller, of a furnace, everything takes place inside this PLC. So HMI, VFD, and all those things I'll be explaining in the coming slides. And the most important thing would be variable frequency drives. The variable frequency. You know about induction motors, and all those DC motors and everything. So in the laboratories, college laboratories, we would have conducted some experiments by connecting directly to a three-phase supply. But in industries, what they do is they connect these incoming supply to a VFD. So these VFDs would in turn give the power supply to the motors. What happens inside a VFD is that it converts AC to DC and again DC to AC. So this is a subject we would have learned in power electronics. I hope so in third year. So this is of very major thing used in industries. So without VFDs, there is no motors running in industries. So whatever we learn in the college, so that will be directly applied in the industries. So we have to get an expertise knowledge in the basic concepts that we learn in our college. So that is what I want to emphasize on. So next comes the temperature controllers. Temperature controller. It is used for monitoring the temperature in a furnace. In power plant engineering, you have all learned about the temperature, the furnace heating and everything. So temperature controllers maintain the temperature inside the furnace and gives you uh, uh, the data, whatever is required. Next comes the supervisory control and data acquisition. In Industrial 4.0, SCADA is very, very, very important. So without SCADA, there is nothing in Industrial 4.0. So SCADA is nothing about the data acquisition, the data that you have got for a product that you manufacture. That is what we call it as SCADA. And with the help of SCADA, you can control everything that is running on the shop floor. Shop floor is nothing but the assembly lines where the product is getting manufactured. So the product getting manufactured and all those data can be remotely accessed through SCADA from your cabin. So that is a main importance of SCADA. So next comes the computer numeric control, which you would have heard of CNC machine, precision tool making machines. So these and servo systems are totally similar. There is only a minute difference. Computer CNC machines are totally dedicated machines that is used for precision, 0.0001 mm accuracy if you require for a machine, that can be achieved with CNC machines. Servo system is the same, but it is customizable. So you can use it for different applications. So robotics, you very well know about robots, what are robots, and the applications of it. It is used for pick and place application, spot welding application, and many other applications also. So in the coming slides, I will be explaining about what is automation is and what is factory automation. So I have taken a case study. In the below picture, you can see a man controlling a hand valve which supplies air and oil for controlling the temperature in the furnace. What he is doing is he is continuously monitoring the temperature gauge. He just wanted to adjust the valves based on the temperature that is being shown on the temperature gauge. So you can see the picture. So if he wants to reach a temperature of 500 degree, he'll adjust the hand valve mechanically. So let us see the drawbacks of manual heating. Reading the temperature and adjusting the valve manually will be surely a difficult task, because operator has to dedicatedly be there for changing the temperature, adjusting the valve, and increasing the temperature. So the next drawback would be overshooting of temperature. There is always a overshooting of temperature. If he wants to stop exactly at 500 degrees Celsius, it is impossible. It is possible, but it is a very difficult task. So you cannot accurately control the temperature, because that is not controlled by a machine. It is totally depends on the skill of an operator. So there is a possibility of human error noting the values. Suppose if you want to monitor the data's month data continuously, it is very difficult. So every 5 minutes, if I want a data, I want to know the temperature inside the furnace. I have to dedicate a person or an operator to note down all the values at regular frequency, at regular intervals, which is very impossible. So noting the values at a specified time interval would be very difficult. It requires human effort, therefore accuracy is also affected. Here accuracy, I am noting it as the errors that we make during noting the values. So when you give that option to an operator, that will be there will be lots of human errors as well. So the above drawbacks can be eliminated by introducing an automation in the above process and thus increasing the efficiency. So in the next slide, I'll be explaining how PLC comes into this play. So here in this picture, it shows a man controlling a hand valve with the temperature gauge as a reference. The next slide, I'll show what automation is. So in this, so the same temperature control is there, but the human operator is totally avoided. So what happens is the temperature controller, from the temperature control, there are many types of temperature controllers available in the industry. So what happens is from 0 to, if a temperature control is there, which controls 0 to 650 degree, it gives an equivalent output of 0 to 10 volt. If the temperature reaches 650 degree, it gives an output voltage of 10 volt. So there are many types of temperature controllers. What I'll do is, I'll get a 0 to 10 voltage analog value from this temperature controller, and I'll give it to the PLC. So when the temperature gauge reaches 650 degree, I'll get an equivalent analog voltage of 10 volt to the PLC. I'll get it from the temperature controller. So inside the PLC, I'll program in such a way that when when this 10 volt reaches, I should cut off the valve. So HMI is used to monitor the values, what the current temperature is going on, and I can also log data inside that. So I'll digitally control the valve using the 0 to 10 volt output. So you would have seen those valves which are controlled with 4 to 20 milliamps and 0 to 10 volt. If you give 10 volt, the valve will totally open, and if you give 5 volt, it will open accordingly. So based on the temperature, I'll program the PLC in such a way it should open only in a partial way. So I'll program, the program will be done only once, and I don't have to modify again and again. So I'll control the valve and directly give it to the furnace. So here what happens, the PLC totally takes control of the mechanization of controlling the valve, oil and air valve. So there is no human intervention at all. So the risk of human is totally avoided. So the controlling human effort is totally reduced, and the error is also reduced obviously. So what is SCADA? Where does SCADA comes into play? So suppose I want to analyze the data, a month data. What was the temperature of the furnace for a month? What is the average temperature? So I can monitor it through SCADA. SCADA is nothing but a database. The database can be Excel, Access, SQL Server, it can be Oracle. So these are all different types of Oracle, database, where the data can be stored to analyze data, analyze the production efficiency. We can take the example of the mark list that arrives, that once the semester results are out, there will be different kinds of data that we analyze. The section-wise data, the subject-wise data. We analyze different types of data that we get. The pass percentage, subject-wise total. So these are different kinds of report. For generating these reports, you need some data, right? So that is what we call it as SCADA. So in the industrial world, we call it as SCADA, analyzing of data. That's it. So even the data acquisition can be programmed in a PLC. You don't have to manually note it down. If you just program it once, that is totally enough. So what are all the advantages of implementing automation in furnaces? So precise control of temperature in the furnace. Even 0.1 degree can be controlled by implementing automation. So then comes the minimizing human effort. So you cannot afford to implement deploy a operator for hours together. So this can be totally replaced by implementing PLC. So analysis of data can be done on various factors. The reports which I told you, month-wise data, hour-wise data, so yearly data. So everything can be analyzed remotely. You don't have to go near the machine at all. So human accidents or harm can be avoided since there is no need for man to go near the furnace frequently. So this is a very important thing in today's industrial world, because going continuously working near a furnace is a very difficult task for the operator. So when automation is implemented, this is totally avoided. So as I said before, data acquisition can be done at a remote mode. Then high production rate can be achieved in an efficient way. So by analyzing the data, you can very well analyze the way of correction that has to be done to improve the production quality and as well. So if I suddenly say about industry 4.0, students might get confused. So what is 4.0? And they might have a confusion. What is 4.0? So experts have classified the industrial technology into different categories: 1.0, 2.0, 3.0, and 4.0. So everything started from industry 1.0. The revolution started from 1.0. And in 1.0, everything was mechanization. So there was no electrical energy. There was nothing. Only steam power plant. They used steam power plant. And the first weaving loom, that is textile industry, was introduced during this period. Mostly they used animals also for making the job done. So this was industry 1.0. It was totally mechanical. So the next comes the industry 2.0. Here is when electrical energy was introduced. When electrical energy was introduced, it made them very simple to manufacture machines, and everything. The mass production assembly line was started during this period. The manufacturing of cars, automobiles. Ford was started during this industry 2.0. Ford and all those automobile industries, mass production, textile industries, everything started during industry 2.0 when electrical energy was introduced. So industry 3.0. 3.0 is a very major industrial revolution that took place, because PLC, IGBTs, standard state relays, solid state relays, and all those integrated circuits were introduced during industry 3.0. So this is where automation started. Automation revolution started during industry 3.0. And now we are in industry 4.0. We have not achieved it fully, but we are in the way of achieving it. So industry 4.0 is nothing but IoT. So you would have very well heard about IoT, Internet of Things. So everything is on the cloud. Cloud is nothing but internet. So whatever the data that is being generated in the shop floor, that is in the assembly line, you will be able to monitor it remotely from any place, any part of the world. So this is what we call it as industry 4.0. Industry 4.0 is nothing, in a simple way, it is nothing but cloud, internet of things. You can assume it that way. So in this picture, you can see what industrial 1.0 is. So it was in the late 18th and 19th century when mechanical production facilities was introduced into the world. So in the picture clearly denotes everything was mechanical. There is no electrical energy involved. So the first weaving loom was introduced during this period. So this is the starting of the industrial revolution. So next came the industrial 2.0. So the beginning of 20th century started the second industrial revolution. So as I said before, Ford industries and all those manufacturing, assembly line manufacturing industries started during this period. So the major contribution to this was the electrical energy. So electricity was introduced, and it became a standard practice for them to produce mass production of goods. Okay. So many machines were introduced during this period, and also it was very useful for them because it was easily portable. Since electrical energy was there, it was easily portable for them. So industrial 2.0 can be shortly described as mass production and assembly lines. So industrial 3.0, the most important industrial revolution that took place. So this is the period when transistors, integrated circuit chips, everything was started. So the programmable logic controllers were also introduced during this period, and there was also robots and many cutting-edge tools were introduced during. Industrial 3.0 started approximately around after 1960. That is what the data shows. It was started after 1960. So that is when PC, industrial computers, and all those electronic devices were majorly concentrated and manufactured. So next comes the industrial 4.0. Now we are standing here. Now we are in the period of industrial 4.0. So the marking the 21st century started 4.0. So everything is Internet of Things with different manufacturing techniques through cloud. So what happens is, so remotely you can access data. If there is a manufacturing plant in Chennai, I can able to monitor it remotely from Delhi. So wherever any part of the world, I will be able to monitor the production data, analyze the data, how many components are manufactured. Uh, I can get the data remotely. I don't have to directly go there and visit the plant. So this is industrial 4.0. So and also most advanced robots and artificial intelligence, everything was uh, started to establish during this industrial 4.0. So what is Mitsubishi's contribution towards this industrial 4.0? Now, as far as Mitsubishi is concerned, it has been it is a it has played a major role in the industrial 4.0. That is, it has got SCADA options, and it is the first company, first company to introduce CC Link IETSM. So in the before slide, you would have seen all these industry 4.0 uh, things, cutting edge technologies and Internet of Things. So this CC Link IETSN is nothing but a single cable. So if you consider a factory automation, there will be different kinds of things. You can see, for example, in this picture shown below, there are robots, inverters, servo motor, HMI, PLC, and there are lots of different industrial products available. But what is the difficulty in this? The difficulty in this would be connecting everything in a single cable. So Mitsubishi has contributed uh, to you know uh, bring everything in a single network, single cable, single Ethernet cable. So this is the first company to bring this. So I'll show a video on this. You're able to see the video. Is the video visible?
Yes,
Yeah.
Gautam, you can
Yeah.
proceed. Video is visible.
So I'll just pause the video in between and explain you the concept also. So this is the industry, and there are different number of factory automation products inside the industry. So everything are connected with different types of wires. You can see the orange wire that is used to connect different applications, and the blue color wire that connects different servo motors. So everything are connected in different cables. So what happens is there is a lot of maintenance problem will be there to troubleshoot the problems. But Mitsubishi has come with a very good solution for this. So this comes under Industry 4.0. So there is IT communication, motion control, and different kinds of equipments are connected differently. But what does TSN do with this? So if you can see, everything has come in a single cable, single Ethernet cable. So Mitsubishi is the first to implement this CC-Link IETSN, which is very well used in Industry 4.0. So if you can see, there are different types of application running at different speed. One is 1 Gbps speed, and the other one is 100 Mbps speed. One is 1 GB, and there are different kinds of speeds available in the factory. But what CC-Link IETSN does is that it integrates everything into a single cable and communicates with the PLC. So that is a major advantage of this. And throughout the industry, a single cable is enough to communicate with the server. So that is a very great advantage of this PLC. And the world is moving towards this time synchronized, time sensitive network. So every portion has got a specified time to control. So everything can be monitored remotely, as I said before. So whatever is happening in the shop floor can be monitored remotely through this IETSN. So this is nothing but SCADA. So the values that are being running in the PLC can be remotely monitored from anywhere in the world. So this is a perfect example for Industry 4.0. So this is data analytics. So the different production data, everything can be monitored and remotely accessed for the improvement of the production. So this is IETSN. I think Mr. Prashanth would have explained you about e-factory and all those things. This is totally integrated with that. So this is the shop floor. The base thing is the shop floor, and this is edge computing, and this is the IT system. So this is e-factory solution. Mr. Prashanth would have explained you before session. Now I'll continue with the PPT. So this is TSN. So different kinds of communication can be performed in a single network. That is, you would have heard of Modbus communication, serial communication. Everything can be integrated in a single cable, and this TSN serves that purpose. So this is IETSN, CC-Link IETSN. So, as I said before, I'll be explaining the projects that I have done because Mr. Prashanth would have explained you about the different products in Mitsubishi PLC and what is automation and everything, all the automation related products. So, I thought it will be very useful for the students if I explain some of the projects I have done in the factories. So, this is the first application that I will be explaining. So, this is nothing but steel rod cutting machine, automated steel rod cutting machine. So as you can see the picture, that the right hand side part was only there. This left hand side part was not there at all before automation. So the main aim of this project, this is not the steel that we use for building construction. This is totally for automotive industries. You would have heard of that piston valves that we use inside the engine, internal combustion engines. So to manufacture that, different types of steel rod lengths are required. So based on the requirement, uh, different kinds of steels will be cut using this machine. So if I require a 4 meter steel rod, what the operator does is he'll run these rollers in the machine, and he'll measure the length, measure 4 meters of length, and he'll cut the machine there manually. He'll be cutting it with a very big industrial cutting plate that will be around 6 to 8 kgs. But with automation, we have totally avoided this part. So we have automated everything, and everything comes in automation. I'll show a video. Before that, I'll just explain the process overview before automation. What was there before automation? So steel rod will be unmounted from the coil and will be fed using these rollers. As you can see the picture, there are 4 rollers. So between these rollers, the steel rod will be moving. So these rollers will be pressing against each other, and it will be pushing the rod outside. So this was the process before, and they'll measure the length of the steel rod manually. They'll measure the length, 4 meters of length or 3 meters of length, according to the customer's requirement. They'll measure the rod and cut each and every rod individually. So that was the very difficult part for the operators. So the operators have to stop the rollers once the required length is reached. Once the required length is reached, the operator stops the rollers. Then with the help of cutting tool, that is it will be like a very big cutting player. It will be around 6 to 8 kgs. They have to move that and cut these steel rods by measuring it. So for each and every rod, the feeding process will be stopped. So the customer asked us to automate this completely, and this was their requirement. Speed of the roller must be 20 feet per minute, and the production rate was 1 rod for every 2 minutes. So every 2 minutes, they'll be able to produce only 1 rod because they have to stop the roller, cut the uh, cut the steel with the cutting player. So this required 2 skilled operators. Skilled operators nothing but he has to get trained in this process, because it is not that easy to cut this steel rod. There is a lot of safety issues also. So cutting accuracy depends on operator's efficiency. So before automating this, the accuracy was around 25 to 40 mm. So there will be a difference of 25 to 40 mm with different steel rods. So there was no accuracy at all. So cutting not possible in the absence of operator. Production is totally dependent on the operator. I want to just show a video of this before automation, how it was working.